water. So we're going to use small bits, so like a small firecracker versus a big, you know, heavy. To give you guys an idea of how reactive it is, it came in these big metal tins full of clay, and it also came in this plastic bag. It was all sealed in this metal tin. I had to pull it out, and then I have to undo it, and then it's still under oil. Right? The oils to keep it from getting into the reacting with the water in the air. So it's so reactive that the moisture in the air will actually cause it to react. So that being said, and everyone's caution being up, we're going to dump a couple of pieces out. And again, I'm only going to use a couple of small pieces. And I want to show you guys what this looks like underneath the camera here. This is what lithium looks like in real life. So this is just all lithium atoms, and it's a soft metal. It's like butter. You can actually cut it with this spatula. So if you look at the inside, can you guys see that?
Kind of like a bean. It looked like a bean.
Alright, so it's actually very shiny in there. So it's a metal, so it's very shiny, and if we let it go out in the air long enough, it would actually start to rust as we talk. So if I wiped off all the oil, it would actually start rusting right away because it's so reactive. Like if you leave a car out, it'd take like several months before you get rust on it. But this stuff would rust in the period of an hour. So we're gonna take a look at what this does under with some water now. Now, when it reacts with the water, remember this has one valence electron. It wants to get rid of it. And anytime electrons move, we have energy, right?
We have energy.
So like electricity. Electricity, all it is electrons moving through wires. So that's what gives it power. So the same thing here, we're going to see what happens when the electrons move. And I'm going to start off with a pretty small piece. All right, and you guys can see what happens. And what's going to happen is it's going to react with the water. It's going to give off hydrogen gas. And have you guys ever heard of hydrogen gas?
Yeah.
All right. Where have you heard of hydrogen gas?
Gentry.
Say what?
Gas station.
All right. Maybe at a gas station they're talking about hydrogen fuel cells. All right. Have you guys ever heard of the Hindenburg?
Yeah, I couldn't remember the name.
All right. What's the Hindenburg?
It was a blimp.
It was a blimp that got blew up.
Right. It was a blimp that got blew up. So it had hydrogen in it. And someone sparked a match and caused the Hindenburg to blow up. So what we're going to see when this reacts is, sorry. All right, so what you're going to see is that it actually starts spinning and going in circles, and what that is hydrogen gas coming off the water. That's how reactive it is. All right, so that's just a very small piece. And lithium, remember, is less reactive because it's at top than sodium. All right, the other thing that you need to know is that since this is called the alkali metals, it actually makes this solution basic. All right, so what we can do is put some indicator in here, and if it turns an orange color, it actually shows that it's causing pink color.
Pretty.
It's actually causing a basic reaction. So that's like soap or bleach. It's actually making it more basic than acidic. All right, so I'm going to dump this down the sink and put some fresh water in there. And then we're going to try a bigger piece to see if we can get a little bit more reaction. Alright, we don't need a whole lot more. I'll put some of the indicator in so you can see it happen before your eyes. So here's the few drops. Alright, so no color change. Again, we're going to do a little bit bigger piece so you guys can hopefully see it. Alright, here we go. And I'm going to dim the other light, I think. Oops. Alright, we do have a slight color change. So you can see the gas coming off of there. That's actually hydrogen gas. And if I wanted to, I can actually light that on fire because just like the Hindenburg, that gas is flammable and actually explosive when you get it into tight confines. So we're talking about highly reactive metals. So this doesn't react like normal metals, like iron and gold. If you washed your hands, you're not going to light your finger on fire, right? So this is a lot different, a lot more reactive. So that's that electron jumping off, that outer electron. All right. Well, I think that's good for lithium. So what is it? Sodium, is it more reactive or less reactive?
More reactive.
All right, so we would expect a lot more of a reaction here. So we're going to go ahead and get out some lithium. Again, we got to get it out of the plastic bag. And
What do you mean sodium?
yes, sorry, sodium. Thank you.
You're welcome.
Oops.
Oh.
That's what I do. All right, so these are in even smaller chunks than lithium because that's how reactive it is. I'm going to show you guys this under the microscope or the thing here. So this is a piece of sodium. Again, this is very highly oxidized, but this is even softer. And if you look at the inside, you can see hopefully the shiny. Can you guys see the shininess? It's hard to see.
Yeah.
So again, this is very, very reactive. It has to be under oil, so it doesn't react with the atmosphere's water, so the moisture in the water. So we're going to see a little bit more of a reaction. So I'm going to dump this down the drain again. Again, you'd see with the indicator a change of color, but I'm not going to put it in there because you've already seen that a couple of times.
There's a video on YouTube. Dude drops like an eraser size piece or something in the bathtub and it explodes.
All right.
It's like this small, drops in the bathtub and it just explodes.
All right. I might want to move this. I'm going to move this slightly out of the way so it doesn't pop up and ruin the camera too much. All right. So I'm going to start off with a small piece again, and you guys will see what happens here. So, all right. So this is a lot more reactive. The other cool thing about this is it makes a sphere of sodium right on the top, and I know it's, since this is small, it probably won't pop. But there's a lot more heat coming off of there. It's moving around quite a bit. Again, hydrogen gas is coming off.
And it's orbit.
Yeah, it's like spinning around there, so it's so reactive. And this is just a very tiny piece. It's even smaller than the lithium. But how many of you guys want to see a bigger pop?
I want to see a big one pop.
All right, so let's
Dump the whole thing.
dump the whole thing. Actually, if you get enough of it, it will explode. This can actually break the glass on here, which I don't want to do, but we'll do a big chunk. Why not?
Yeah.
I'm going to move back a little bit. All right, so a lot more heat.
Look at the flame.
Sometimes it catches on fire.
Laptop fire.
I smell smoke.
Well, it's not. Probably not fire. It's not actually smoke. It's just hydrogen gas.
Is it gonna pop like?
Oh!
Oh my.
There we go. Put itself out.
I love the smell of matches.
Really?
Yes, they're my favorite. I wish my room
Make
was
sure I'll
like-
tell your mom that.
My mom knows.
All right. That's kind of lame. I want a bigger one.
Yeah, let's make a big chunk.
All right, just for you guys.
Let's make you regret it.
See, I don't want one too big.
He dropped it now.
All right, we'll do a bigger one.
Can you do it in the swimming pool? We buy that stuff.
Wipe off the oil so you get more of a reaction. All right, here we go. Ready?
Yeah.
Boom.
I'll let it burst.
Whoa.
You can hear it sizzling. That's heat. It's actually vaporizing some of the water. Sometimes it catches on fire, sometimes it doesn't.
Time to light it. Well, I thought I did it upside down.
Ooh, starting to spark a little bit. It actually helps if you have it in a smaller container. I'm not trying to make a projectile.
Light it.
Alright.
Oh, it's so bad. Ooh.
Turn the light on. Alright. Next thing I want to show you guys. I want to show you guys how the alkaline earth metals react. So the alkaline earth metals don't react very well in water. You actually have to heat it up. Anybody in here interested in firefighting or? Alright, so if you go onto a